Lab 4. Here we're going to be using hydrated salt, copper sulfate, and what you'll see, it's a blue powder. A lot of copper salts are blue. So there's actually, per molecule of the copper sulfate, there are 5 water molecules that are trapped in the crystal lattice, and it makes up the entire molecular formula of the compound. So these are very common in chemistry. These are known as hydrated salts. And we'll actually see 2 of these in this particular lab. Now the mass you see here, you don't have to record that. We just want enough of the sample to get a good amount of water coming off of it. There is that blue powder. And it's even though there's 5 water molecules trapped in that crystal lattice, it's a dry solid. I mean, if you put it in your hands, it would feel like a powder. There's no particular reason I'm doing this in the hood, just sort of convenient for me. The only thing that's going to be coming off of this crystal or this sample is just water vapor. Setup's pretty simple. Just a test tube clamped at a particular angle. You'll see it in a second. And again, there's that pretty blue salt. Spread the crystals out just a little bit. That'll help the water get released from the solid a little bit more easily. What we're wanting to do here is we want to heat the sample, we want to drive the water off, but we want to collect the water. And so that's why you see it being set at this particular angle. Closing the air valve, okay, closing the gas valve. Typical procedure for lighting a Bunsen burner. I've turned on the main valve for the lab. There we go, opening up the gas valve a little bit until I'm just hearing the gas coming out of the Bunsen burner. That flame there is hot, but it's not as hot as it can be. So to get the hotter flame, I'm going to open up the air valve just a little bit. That gives me my proper gas to air mixture to have complete combustion. Again, it's pretty simple. You just heat the solid, water will be driven off, and then we'll collect some of that water in the test tube down there. It's being held in the Erlenmeyer flask. And you'll see it'll drop the water off pretty easily from this sample. You might be able to tell it's getting a little bit white here. Take a closer look. Yeah, so that white color you see on the solid, that's not some artifact, that's real. When the calcium sulfate gets dehydrated, it goes from blue to white. And you can actually see the water being collected on the top part of the test tube where it's cool. And toward the end, you'll start seeing the water actually drip out of the test tube. There it goes. Now at this point there is enough water in there to test it for the next step, but I decided just to be aggressive with the heating and just drive more of it off, seeing how much of the blue color I can remove from the sample. Now from this perspective, the powder is pretty much all white. Um, I think there's a little bit of blue left, but not much at all. When that test strip is blue, it indicates that it's a dry sample. And right now it is blue, so it's fairly dry, but hopefully you'll notice that once I've heated up the test strip just a little bit, it actually turns a darker blue. You might be able to see that subtle change in the video. This step is harder than you think. I kept burning the test strip pretty easily, even though I'm a few inches away from the flame. And notice what happens there. So when I put the water on that test strip, it turns pink. Again, blue indicates it's dry, pink indicates that there's water there. And you can confirm that test by just taking water, distilled water, and then putting a drop of it or so on the test strip, and there's that color change. So it's just a simple little test to confirm that the liquid that came out of that solid sample is water. And when I tilt this thing back up, what you'll notice is a little bit of water runs back. See that blue? A little bit of water comes back to the, touches that solid. And now it forms a blue color right at the tip.